Hello dear students. Today the topic of our discussion will be the interior of Earth. First, before we dive into the topic, let us see how Earth and all the other planets of our galaxy and also the solar system and also the universe were formed. There is a popular theory called as the Big Bang theory. As the name suggests, everything that is the constituent of our universe today was tightly packed into a single body. Now that single body was the precursor to our universe. So what happened one day was there was a great explosion, also called as the Big Bang, wherein the constituents of this mass were broken apart into various space debris. So this is the initial stage of our universe. So there were a lot of space debris floating around, in the sense they are rocks. These rocks were floating around in space. Now what happened was, we know that every body which has a certain amount of mass will be having a pull, a force called as the gravitational force. This gravitational force is a type of attractive force that binds together the solar system and the universe. Everything that is present in our existence is in its place thanks to the forces of gravity. Now, thanks to the gravitational force, these huge chunks of rocks started coming closer to each other. See, this rock, the gravity influenced these rocks to come together in one spot. In the same way here, in multiple regions across the space, wherever there was sufficient amount of debris, these debris started coagulating together. Now, when under extreme gravitational force, there began the fusion reaction. Now, as a byproduct of this fusion reaction, a lot of heat and energy was dispersed. So, upon coagulation, these space debris, due to the fusion, the heat that is being gotten from the fusion reaction, the certain spherical shaped objects began to form. Now these were hot molten states. They were in a molten state. Our Earth also was initially in a semi-solid like state. Now these molten rocks, as we know, space, there is no source of heat. All the heat that we receive for our solar system comes from the sun. So due to a lack of the heat presence of heat, and also these are not few chunks of rock, there were millions of rocks that began to get attracted to these centers of gravity. So therefore the planets were starting to take form. Initially, we all know that when we in a semi-solid state, all the densest material will make its way to the center, and all the light materials will be at the surface. Thanks to the pressure and density, the most densest elements such as iron and nickel came in the center of each of these spheres, which we also call as core. Now all the lighter elements such as silica, magnesium, aluminium, they all were in the periphery of the planet. So therefore, due to sorting done by the density, we have various layers present in a planetary body. So this is a basic understanding of how Earth was formed. Now next, how do we study the interior of the Earth? For the study of interior of the Earth, we have two major classifications. First is artificial sources and another is natural sources. Now what are your natural sources? Volcanism, Volcanism is the process of hot molten lava that seeps its way from the astrosphere to the surface of the earth in the form of volcanic eruptions. This entire process is called as volcanism. So via volcanic eruptions, by studying the lava or the molten product that comes out from the volcanic vents, we can have an idea about the interior of the earth. Next is we have meteors. As I told you, every planetary body in this universe came from a single particle. Therefore, there is not much difference between Earth and various other planets or celestial bodies. So therefore, when we study the meteors that have landed on Earth, we can easily make out the interior of the Earth, because in a sense meteor are also the same but a very small size, a minute size of the Earth, as you can see. So there are other artificial sources to study the interior of the Earth. First is deep sea drilling. Now, in the quest for finding petroleum, a lot of humans engage in deep sea drilling. While drilling the ocean floor, everything that is drilled is brought to the surface, and that substance is being studied to get a better understanding of the interiors. Next is, and also mining. In the process of mining, we dig deep into the earth's crust and we obtain materials. So, but deep sea drilling, volcanism, meteors and mining, these are all limited. As we know, the highest depth, greatest depth that humans have achieved so far is only 8 kilometers. We were able to excavate only 8 kilometers below the crust. That is not even the complete crust of the earth. So therefore, these sources are quite limited in their nature. So therefore, there is another source called as seismology. Seismology is nothing but the study of earthquakes or the waves that are present in an earthquake. We have primarily two waves, that is P waves and S waves. P waves are primary waves, S waves are secondary waves. Primary waves are a bit faster compared to secondary waves. Secondary waves travels at almost half the speed of primary waves, and secondary waves are similar to that of light waves. So most of the damage in the earthquake is caused by these primary waves, because primary waves can pass through solids as well as liquids, whereas secondary waves only propagate through solids. And these primary waves are directly proportional to density. Greater the density of the medium, faster the primary waves will travel. Therefore, less the if the density of the medium is low, the speed of these P waves will also be less. So by studying these waves, and also by studying the waves, their velocity, direction and shadow zones. Velocity is nothing but the speed. But depending upon the speed of the primary waves, we can bring out an understanding of the interior of the earth. See, everything is done based on scientific study. There is no person on this world who has dug deep into the core and seen all the constituents of the interior of earth. We formulate the interior of the earth based on scientific research and data. So by studying the speed of P waves, that is the velocity of P waves, we get an understanding of the interior of the earth. According to research, for the first 100 kilometers, the speed is great. Then as we go below 100 kilometers, there is a fall, there is a reduction in the speed of these P waves. And again, after again 500 kilometers or so, again there is a spike in speed. So as we go deep into the earth, first 100 kilometers, the speed is constant. That is, it is very quick. When we reach the 100 kilometer mark, the speed suddenly slows down. The velocity reduces. And again, after a few kilometers, there is another, again a spike in the speed of P waves. By this research, we can find out that in between the 100 kilometers and the below part, we can find that there is, this is solid, this is solid. There is a presence of a semi-solid structure present between these two layers of hard solids. Now direction. See, sound waves, direction and shadow zones. See, example, this is the earth. P waves have their own shadow zones. S waves also have their own shadow zones. This is the core. Okay. See, P waves originating here. So this is the epicenter of the earthquake. P waves without any hindrance will move and propagate easily. But when they reach to the outer core, there is a certain deflection. And as they enter out, they leave the core, they follow the same trajectory. So, therefore, this region where P waves are not recorded are called as shadow zones. And similarly with S waves, we know, I told you that S waves can propagate only through solids. So, S waves began propagation here, and all the waves, this is the shadow zone of S waves. That means there is no recording of S waves here. Here, these regions are called as the shadow zone. Here, P waves are not recorded, and this entire bottom region, S waves are not being recorded. Now, why is this? It is simply because the core, we all assume that core is solid instead, whereas it is not the truth. The inner core is solid, but there is a part of the peripheral core that is in liquid state. This is due to extreme radioactivity that goes on within the core of the earth. Therefore, the outer part of the core is liquid. Therefore, we see here S waves can only make it up to the outer core. Below, they cannot penetrate the outer core because, as I told you, S waves only pass through solids. Here we see a deflection because of the property of refraction. When any wave moves from a rarer medium to denser medium, there is a shift in its trajectory. And therefore, this is the reason why we have two shadow zones present regarding both P and S waves. This is the seismology, which is an important topic for understanding the interior of the earth. Now let us see the classification. We all know the lithosphere, that is the rocky part of our earth, is called as lithosphere. This lithosphere or crust, the basic classification is crust, mantle, and there is core. In core we have inner core, outer core. Inner core is solid in nature, outer core is liquid. In mantle we have upper mantle and lower mantle. Upper mantle, half of the upper mantle is in semi-solid state, which is called as the asthenosphere. Majority, 99% of all the volcanic activities on the planet Earth are thanks to this asthenosphere. This part of molten lava, because see there is a general rule that every 32 kilometers every 32 kilometers we go deep inside the earth, there will be a 1 degree Celsius rise in temperature. So the deeper you go, at the rate of 1 degree, the temperature will begin increasing. Therefore, we have a molten asthenosphere. But as you can see, since the asthenosphere is molten, why isn't the subsiding layers also molten? Why all the way up to the lower mantle there is a solid structure? It is because as we go deep, there is also an increase in pressure. There is an increase in density. As we go down towards the core of the earth, the temperature will increase, pressure will increase, and also the density will also increase. So since there is an increased pressure and increased density, the boiling point or the melting point of these materials is increased artificially thanks to the pressure and density. Therefore, this part is mostly solid. So now this is the upper mantle and lower mantle. Upper mantle contains the asthenosphere. Now above that we have crust. There is continental crust and oceanic crust. See, crust can be divided into two parts: Sial and Sima. Si stands for silica. It is the major constituent of your sand. Your sand is majorly made from silica. And this Al stands for aluminium and Ma stands for magnesium. So the first 30 kilometers all over the world you have Sial. And below that you have the comparatively more denser region called as Sima, which is silica and magnesium. So therefore you have continental crust, oceanic crust. Oceanic crust you can loosely refer to it as Sima, because on the ocean floor, due to excessive weathering, the Sial layer is almost weathered completely. So therefore oceanic crust can also be called as Sima. Continental crust is your Sial, which is for about 100 kilometers. Now next, after 100 kilometers, you have the asthenosphere, the region for all the volcanicity. See, there are certain fissures on the crust from where lava emerges and it causes volcanic eruptions. So next we have the lower mantle, which is solid asthenosphere and mantle. After that we have the outer core, which is molten, and at the depth of 6,370 kilometers you have the inner core. So this is the basic understanding of the Earth's interior. There is also another topic I would like to teach, that is mantle plumes. Mantle plumes. As I told you, 99% of all the volcanic eruptions occur from the asthenosphere. But in certain cases, in very rare cases, such as the Reunion hotspot, your present day Maldives are lying above the Reunion hotspot. So this is a geographical location where this is the core, this is the earth. There are few regions in the planet where there is a huge crack that is formed from linking the outer surface to the outer core. We know that outer core is molten in nature. That means it is also hot magma. So sometimes magma rises up above this through this crack and it causes volcanic eruptions. These are called as mantle plumes. Volcanoes that originate from the outer core are called as mantle plumes. See, volcanic activities, they are scattered. Once a crack might open up, the crack might get filled up, because we know that the crust is essentially Sial is floating over Sima. That means there are plates that are moving around. Since the plates move around, the regions of volcanoes might shift, but these mantle plumes are permanent in nature. That means since the beginning of Earth till now, this crack has remained, and magma, whenever there is an increased concentration, has been leaping upwards. So this is it for today. Thank you so much.